We live on the cutting edge of physics, material science, engineering, and nanotechnology. Because at Lockheed Martin, we're engineering a better tomorrow.
So, good morning, everybody. Thank you guys for coming out to see us here at 11 a.m. We are the Traveling Science Show from the Franklin Institute, and it is time for Science Showdown! Who's ready for Science Showdown? Nice. So, we are going to introduce our science athletes. First up, let's hear it for the Beard.
Woo!
Oh, Beard, you missed
everybody,
the stages.
personally say hi to everybody because there's nobody. Hi, everybody. How you doing? The Beard's in the house. You know what they say? Yes. You know what they say, ladies and gentlemen? A man grows a beard, but a beard grows a man.
And next up, let's hear it for the Kid.
It's the Kid, ladies and gentlemen, the Kid.
The Kid. Welcome. Kid's a little new to this.
Come on, Kid, we got a chat.
Stairs are over here. So welcome, everybody. This match is scheduled for 7 rounds. And
7 rounds!
I can give files beforehand. Now, during each round, we will choose a topic from the hat of science, and each athlete will perform a demonstration based on that topic. In the event of a knockout, you guys are doing it wrong. If each demonstration, or if the demo is lame, the athlete will be allowed a rebuttal. I want a clean fight from you guys. No hitting, spitting, no punching, unless absolutely necessary. I will award fouls based on bad science, bad demo, bad puns, or bad hair. And during the show, you guys are going to help me choose the winner through
That's
your
right.
applause and maybe the tossing of money on stage. I do accept bribes. Thank you very much.
Oh.
So, are you guys ready for some Science Showdown? Are we ready for our first topic?
Uh-huh.
All right. Everybody give it up for the Hat of Science.
The hat of science, ladies and gentlemen.
Athletes, are you ready?
Oh, the Beard's ready.
Beards ready? Kids ready?
I'm ready.
All right.
All right, what do you got?
Our first topic is Lycopodium. So,
Okay, like a podium, like a podium.
everybody, athletes, you must perform a demonstration based on Lycopodium. Audience, for those of you who may not know, Lycopodium is the spore of a club moss. And each grain is actually a little bit smaller than the average width of human hair. They're about 33 microns. That's 10 to the negative 6 meters across. And we can do some pretty cool stuff with it. So, let's give it up for the Beard first.
The Beard first. Well, ladies and gentlemen, thanks for coming to the competition today. I'd like to encourage everybody here today to find out what you're good at and then really go with it. I happen to be really good at blowing fireballs. So for today, I'd like to blow for you a fireball. Here I have said Lycopodium. It is very fine. Has anyone ever breathed in toner? Okay, that's really wrong. Don't do that. This is as fine as toner. I have a little bit here. I'm going to light it, but you'll notice that nothing really happens. That's because we need 3 things, that fire triangle, in order to have something to burn. We need heat source, we need a fuel, and of course then we need oxygen. What's missing here is the O2. Those granules are so close together that they're not actually igniting. So I'm going to use my tube here. I'm going to add a lot of O2 in the atmosphere in between those little pieces of the very small Lycopodium, and we're going to have ourselves a fireball. This is going to be awesome. Okay, did I talk too much? All right, here we go. First we need a heat source. We got that. The key to this trick is not inhaling at the wrong time. Trust me. All right, here we go.
Are you guys ready?
3, give me a count. 3.
3, 2, 1. Oh!
Thank you, ladies and gentlemen. I appreciate that smattering of applause. I can do better.
Let's do better then.
Let's do better. The beer can do better. Reach for the sky. Boys and girls, ladies and gentlemen, here we go.
3,
3,
2, 1.
Woo!
That was better, Beard. Everybody, let's hear it for the Beard. All right, Kid.
What do you got?
Well, I just thought that was really cool, and I love how that fireball was out in the air like that. But I think it'd be kind of neat if we did that same type of experiment, but instead of letting that fire reach out into the air, what if we tried to contain it in a container? Well, I tell you what, here I have a little candle, a little light, and this little light of mine, well, I'm going to let it shine. And then I'm going to put a lid on. This is a cheesy poof kind of thing, and we ate all the cheesy poofs, cleaned it out. And so in a moment, I'm going to spray that same Lycopodium powder into that candle. That's going to excite the Lycopodium. We're going to have a bit of a combustion reaction, but the lid's going to be on. So, well, tell you what, let's just go ahead and figure out what happens here. Here we go. In 3, 2, 1.
Ooh. Kid, we lost a candle.
Is that a foul?
Only if you have money.
Wow. So, pretty
right.
cool.
That was good. That was good, kid, but made a mess.
Oh, yeah, I did make a little mess.
That could be a foul.
It smells like bacon.
All right, so for the first round, let's hear it for the beard. Who thinks the beard won?
Come on, let's hear for the beard!
Oh, that was pretty good. That was pretty good.
And for the kid. Ooh. I'm thinking that was the kid.
Oh,
That's what I
okay.
heard.
I can hear you when you. We're
All right.
space. We can. Okay, I got to bring it. Okay, bring it, kid. That was good. I
Thank
that
you.
one, kid. All right, what's next? How to science.
All right.
Good. Do me well. How to
Here we
science.
go. Next up is, Bernoulli. So we've actually seen a lot of Bernoulli here recently. For those of you who may not know, Daniel Bernoulli was a Swiss mathematician and scientist who said a lot of things about air pressure. So let's see what we got. First up is the beard.
Okay. Well, you know what? I think science should be accessible. Every person here should be able to do some of the things we're doing here, not all, because some of them are actually dangerous. Here's one that you can do at home. All you need for yourself is a hairdryer, which is ironic because I have very little hair left. And you need yourself a ping pong ball, and you can actually do Bernoulli's principle. Here we go.
Oh.
So what's happening here? This ping pong ball is in a stream of air. There's higher pressure on the outside, lower pressure right around the ball. So it's actually sitting in a little pocket of slower moving, faster moving air, which makes lower pressure. Pressure always moves. What's the foul? What's the foul?
Your ball fell and the demo was lame. Come on, beard.
It's called gravity. Not just a good idea, it's the law. Hey.
It's always bringing us down. Isn't it?
Okay. You know what? Was that awful?
Yes.
Was that not very good?
Yes.
It
You
was
can be
okay.
honest with me. You know what? I've got a demonstration that's literally going to blow your socks off. Ladies and gentlemen, I brought with me today the Death Star.
Dun, dun, dun,
What?
dun, 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 dun,
Oh, no.
dun, 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 dun,
I wasn't joking. It's literally the Death Star. All right.
Literally the Death Star.
All right. I believe it's the Death Star upside down. Yes. And I know what you're thinking. You're thinking, why does he have a giant Death Star? And I'm thinking, why not? This happens to be, this is going to be the classic Bernoulli beach ball, except I have upped the size of the beach ball considerably. I know most of you are thinking this can't be done, but here's what's going to happen. We're going to have fast-moving air around 100 miles an hour across the top of the ball. This ball is going to start to spin, and if we have faster-moving air on the top, we're going to have lower pressure, higher pressure on the bottom, and it's literally kind of being pushed up by that differential in pressure. So here we go. This is really difficult to do, so wish me luck with good feelings. All right, ref. Okay.
We got this.
Here we go. Bernoulli's principle on a grand scale, hardly ever seen in the entire world.
It's trying. Oh, woo. That is Bernoulli's principle.
Yeah!
Death Star Nice job, Beard. Look at it go. The ball's literally trapped in a stream of air, and as the beard moves the leaf blower, he can control where it goes. I got it!
Wow.
Everybody, let's hear it for the beard!
That was cool.
That was impressive.
That was cool. Whoa.
Yeah, can we have someone push that back? Now, kid,
Wow.
what you got for us? That was pretty cool.
Well, that was pretty cool, and that gave new definition for me to blowing up the Death Star.
Ha.
And I think the Death Star is pretty interesting. It could pretty much destroy moons or entire planets, but I have something with me using Bernoulli's principle that can destroy toilet paper.
What?
Let me show you what I mean. So, according to Bernoulli's principle, when you have fast-moving air over a surface, that creates lower pressure above the thing and higher pressure underneath the thing. So, okay, that's kind of cool. So, Ref, if you don't mind holding that for me for a second, we're going to apply the same principle. We're going to create higher and lower pressure blowing over this. So, yeah, just tilt it a little bit to this. That way. Okay, great. So, here we go. Let's give this a try. Let me show you what I'm talking about.
Oh.
Woo! Woo, daddy! Yeah!
Okay. And now we made a mess.
Seems like a waste of toilet paper to me. I don't know.
You know what?
That's
that makes
expensive.
It's not too expensive. It's reusable still. It's only cleaning a dirty area to begin with.
For a different purpose, yes.
And you know what? You can TP a home pretty quickly with this device, and yeah, you can have that. That's for you.
Take it
but
home.
You know what?
Souvenirs.
It's your important papers.
And maybe Beard, you could come over and help the ref here. But I thought this would be even more fun.
Wow,
we could do
you
this
got
with
the 5?
a little bit more tea.
Stop counting.
Yeah.
This does look fun, I have to say.
Okay, let's give this an old-fashioned whirl. You never know until you try it. So here we go together. Ooh, yeah. Take that, and that, and that, and... Take that, neighbor.
I don't know what the neighbor
This is
did
when we
to
throw
you, but
things
really.
I don't know. They must have done something dirty to me.
Very bad to you, yes.
Alrighty. So, that was pretty cool. Let's hear it for the beard. Who thinks the beard won
Death
this one?
Star! Death Star!
The Death Star was pretty cool. Pretty cool.
And the kid. Yeah, I'm thinking that was definitely the
I
beard.
better see some points on
Yeah,
the ref.
yeah,
I'm
okay.
gonna
Listen,
take back
listen. Don't make me blow the whistle. Get back to your table.
Huh.
Alrighty.
You were spunky today.
Okay. We're spunky every day. So, let's. What did I just hear? I'm gonna just keep this ready. So, okay, coming up next, we've got rockets.
Rockets.
We are literally about to do some rocket science. Are you guys ready to become rocket scientists? Alrighty. So, first up, let's have the kid start first this time.
Yeah, let the kids.
All right, kid.
All right,
what you got for us?
So, maybe many of you have seen this kind of demonstration before. This is a little film canister. Raise your hand if you've ever used film to take photography. Okay, raise your hand if you have no idea what that could possibly be. Yeah, okay, that's a lot of us. So, film's coming back into vogue. And so this is a classic experiment with an Alka-Seltzer, good for, quelling whatever ails you here in the tummy. And so this thing has in it some citric acid and some sodium bicarbonate. And when that base mixes with the acid, it actually releases carbon dioxide gas. Go ahead, breathe on your hand. Yeah, you just breathed a little carbon dioxide on your hand, amongst other things. And tell you what we're going to do. I actually thought one was a little boring, so I've set up a contraption here with 10 of these empty film canisters, and each has an Alka-Seltzer taped to this base. In a moment, the water that's sitting on the bottom is going to mix into the Alka-Seltzer. That acid and the base are going to mix together. We're going to build up so much carbon dioxide gas inside of those canisters that, well, I'm hoping to see a bunch of tiny little rockets. Okay, let's give this a try. Everything's all prepared here.
I have my doubts, kid. I have my doubts about this.
Here we go.
Here we go. In 3, 2, 1, let's flip.
Okay, the water's mixing.
There's the edge
Water's
of the stage.
Are you
mixing
okay,
with
Raph?
the sodium.
You okay?
bicarbonate and the citric acid, and so they get to mix together.
Nothing.
I see some bubbling happening.
Yeah, I don't see anything happening.
I don't see anything
kid.
happening.
Oh,
Okay, that was tiny.
that was very tiny.
Okay,
Oh.
well, watch yourself. Okay, oh, yeah.
Okay, we got one.
Okay, caught it. That's pretty good. Oh, yeah, oh, yeah.
Oh.
Popcorn.
Big mess here.
Come on, little guys.
Yeah.
Those are loaded, kid. Be careful.
Yeah, they are.
No, this isn't happening.
Foul!
That's a foul. This demo's turning into
Well,
something
we got
else.
5 out of 4, and that's not
a
half
demo
bad.
fail.
That's
That's
half
a demo
good.
fail.
The other thing is, I thought rockets were based on action reaction. This seems.
Well, okay, we're seeing a little action and reaction. Okay, I know what you're getting at. She means the idea that, well, if you put a force in one direction, there's an equal and opposite force in the opposite direction.
no.
So when all those gases push down, our little film canisters went up. Okay, I can show this even better.
Let's. Oh!
I told you that!
Wow. Okay, I like that. I like that. So check it out. Here I've got just a regular 2-liter bottle with a lid on the top, and inside of it I actually have some fuel. Let me see if I can show you what I mean when I say fuel. Okay, here's this, and
Ooh. All right, we got lots of fire.
okay, so some of that fuel is inside of this 2-liter bottle, and in a moment we're going to get that fuel excited. And those gases inside are going to combust, and the only way those gases can come out of this bottle is through this little hole right on the bottom of the lid. So those gases are going to push down. There's going to be an equal and opposite reaction that makes my rocket go what direction? Well, that's a great hypothesis, but I think it's time that we test that hypothesis. Ref, would you like to be our special igniter for this experience?
Sure.
Okay, beautiful.
So, I'm excited to see.
Instead of letting Caitlin sit right next to the rocket launch, we have here what we call a chicken stick. Now, on one end is a candle, and on the other end is a person who's
I have a whistle.
smart enough not to get too close to a rocket launch. Okay, so let's just say it like that. Okay, this is looking pretty good. And I'm going to stand behind you, Ref. So, ladies and gentlemen, can we please get a countdown here together from 10, 9, 8, 7, 6, 5, 4, 3, 2. Heads up!
Science! And we have.
And I think that was pretty cool.
rocket.
All right,
Give
all
it up
right,
for
all
the
right.
kid!
Action, reaction.
All right, Beard. What you got for us?
That's
see
like
this.
that's like the best rocket demo ever, short of launching a rocket. You know what, though? I brought something special with me. I think you're going to like it.
geez.
I'm going to launch a rocket today. Unlike the kid here, I'm going to launch today a 1-liter rocket.
How's that any better?
And I'm going to use a different launching system. I happen to have today a mobile launching system. If you've been following any of these space developments, you know that we now have a rocket that actually goes into space, delivers the payload, and then the rockets actually land back on the Earth. Mind-blowing. Check it out. So here's my mobile launcher. What's unique about this, kid, is check it out. I'm going to be using a Piezo Electricity. You might be saying, what is Piezo Electricity? Pretty darn fascinating. Inside of here, there is a quartz crystal. When this quartz crystal is struck, it's actually up here. When this quartz crystal is actually struck, it deforms and it actually creates electricity. And you can see electricity jumping between my 2 poles right here. This is going to be my heat source. For my fuel, it's a proprietary solution that some folks might remember from back in the day. Just saying, all right, let's fire this up. Ladies and gentlemen, this can be quite loud. So if you don't like loud noises, remember, you carry with you every single day these things that can be your earplugs. 1. In fact, I'll use some protection just to be safe. All right, here we go. Launch number 1. In 3, 2, 1.
Woo! Wow.
Let's do it again.
Yeah,
Let's see it again.
yeah. Do it again.
Do it again.
Do it again. Do it again. Do it again.
Oh, I'm
All
going
right.
to do it again. All right, here we go. In 3, 2, 1.
All right, Beard.
3, 2, 1. What?
Do it better.
Okay.
All right, Beard, what's going on here?
This has a lot to do about that liquid actually turning into a gas. It's very critical. Here we go. In 3, 2, 1. Hold on.
Ew.
Yeah.
3,
That's a little gross.
2, 1.
Sometimes science is a little
Right.
finicky.
That was a good try.
That's a good try. That's
A for
okay,
effort.
Beard. We saw one rocket. I wouldn't let NASA know about this, though.
It's working now.
All right, here we go. One more time. In 3, 2, 1.
Are you okay,
All right, Beard, let's go back.
I'm back.
It was a good try, Beard. I
That was
liked
a
it.
good try.
I
think
blame it on humidity. It's humidity. It's not turning into.
Oh, boy.
I think I'm just gonna make an executive decision here and give this one to the kid.
Yeah.
What? Come on.
Piezo Electricity's cool and all, but it's gotta work. All right, back to the house. Kid, what are you doing? Get back up
I
here.
don't know. I'm having fun with
Kid,
you
get out,
guys.
kid.
Yeah, I mean, look at that cute kid. I mean, that's just... Ah! Okay.
Gotta show these people some science. That's what they're here for, not high fives.
Well, they like both.
All right, next round is rap.
Rap.
Who put this in here?
Spell it. Like saran wrap?
R-A-P, rap. Well, the hat of science has spoken, so let's do some rapping. First up, the Beard.
Well,
I'm ready to hear this.
Okay,
to
all
make
right.
one
Well,
up
I happen
here.
to have. I actually, just in case rap came up, I did prepare something.
I wonder who put it in there. Oh, man, oh.
boy.
Okay, so I hope everybody out there has a favorite scientist. I have two. My second guy is a guy named Galileo, but number one is a guy named Sir Isaac Newton. Check it out.
Okay.
Gravity. Listen, I have a little rap that I wrote about Sir Isaac. I hope you enjoy it, and I have a little beat with it, so if you could hit the beat, this is going to be my rap about Sir Isaac Newton.
I don't know if I'm looking forward to this or not.
You're going to love it.
All right, here we go. Sorry, we're having mic difficulties.
Oh, thank you. All right. All right. Hit it. Yeah! All right, here we go. Here we go. I'm the Beard and I'm here to say Sir Isaac Newton lived back in the day. Apple fell on his head, but he did not dread. Instead, he wrote the 3 laws of motion instead. We're going to break them down, kid. You ready?
Okay, yeah.
All right. Here comes law number 1. Law number 1 says something will stay or keep on moving. It works either way. The speed and direction will stay the same unless another force changes the game. What? That was law number 1 called inertia. It's a funny word to spell, kid. All right, let's go with law number 2. Law number 2, right from the source, so something heavier will take more force. To something lighter to reach the same speed. F equals MA is the formula you need. What? That was law number 2. You got it, kid?
Yeah,
All
I
right.
think F
Let's go with
equals
number
MA.
3,
Got
my
it, I
favorite.
got it,
Here we
got
go. Law number 3. Action and reaction is law number 3. Whatever I push, pushes back on me. Doesn't matter what it is, it's the rule. Every pull has its push and every push has its pull. Everybody say action.
Action.
Everybody say reaction.
Reaction.
Everybody say action.
Action.
Everybody say reaction.
Reaction.
Everybody put your hands in the air like you just don't care. Say action.
Action.
Everybody say reaction.
Reaction.
Everybody freeze.
Woo! Somehow, I don't think you
Let's
came
use
up
a
with that on the
spelling.
spot. All right, that was pretty impressive. I had fun with that. Kid, you can unfreeze. It didn't have to be little.
Okay, good.
You gotta do your rap now.
Okay,
I hope you.
it's kind of a surprise here. Let me just finish up.
Oh, you're really literally writing it right.
Pen fly.
Okay.
I don't know. It seemed like a sneak attack here, but I'm going to give it my best shot here. So many eyes.
It'll be fine. You got this.
I sing like the wind, moving from high to low pressure. And I treasure the science that teaches me how to measure. Wind speed spins the cups of my anemometer. Air pressure pushes mercury on my barometer. The temperature moves the ethanol in my thermometer. And when I jump from a plane, I steadily check my altimeter. See, we all live at the bottom of an ocean of air. It's got weight, and when you stand and look up there, you're looking at a billion times a trillion molecules of matter pressing on every single civilian. Ooh. It might not seem like much, but on top of it, we can sail in blimps, helicopters, planes bigger than a whale. If you know your science, you too can prevail. An airborne person riding on the sky. You can't see it. There's more than meets the eye. With science and engineering, you too can fly.
Nice job, kid. Very emotional.
Thank you.
All right, audience, who do you think? Let's hear it for the Beard and his Newtons rap.
That was good.
Action, reaction, right? And the kid, and talk about pressure.
Newton won. Newton won.
Yeah, I'm a big fan of Newton.
I love me some Newton.
So we got Newton's rap up here.
Newton,
That's
thanks
fine.
you.
All right. Now that we've got the music. So, coming up next, let's see what the Hat of Science has for us. We've got pressure. Kid, you should be good at this. You just rapped about it.
Oh, yeah. My rap was just about pressure and air pressure. Here's someone.
Oh.
Okay, that's for you. Okay,
Let's hope your pressure demo's
that's a
a little
handwritten
better than
rap
that.
there.
Why don't you go?
Pressure demo. Let's see. I have an idea.
I'm
So
thinking.
we brought with us a very special something, which currently is inside of what we call a doer. Now, everybody take a gentle breath of air in. And gently let that air out. 79% of the molecules that you just breathed in are a molecule called nitrogen. Everybody say nitrogen.
Nitrogen.
Nitrogen. We're surrounded by nitrogen all the time. Well, we've taken these same molecules that right now are a gas, and we've made them very, very, very cold. In fact, the molecules in here are negative 320 degrees Fahrenheit. So here's what I'm going to do. I'm going to take some of these liquid molecules, and I'm going to pour them into this Erlenmeyer flask. Now, this flask is the same temperature as the room. So when those liquid molecules get in here, they start to warm up, they start to move faster, they start to spread out, and they become a gas. And that gas is going to want to leave this container, but I have a lid. And this lid has a balloon. And, well, that balloon is going to fill up with nitrogen gas until it can no longer handle the pressure.
All right.
Okay, a lot of steps here.
Safety first.
Safety first.
Remember this negative 320 degrees. You could literally get frostbite just by touching it.
Okay. So we need about a liter of liquid nitrogen.
Liter?
So I'm going to carefully
Oh, man.
pour this into our flask.
Is this like a boring foul? Or like a
Is that an interruption foul?
All right.
All right, kid.
tough today.
You didn't pay me enough.
Buddy,
Oh,
let me borrow these because
Equipment
this can
failure.
get really loud.
okay.
All right. So here
Oh.
we go.
Oh, geez.
Oh, geez.
The liquid nitrogen is turning into a gas. Now, inside of here is nitrogen gas, and that nitrogen gas is filling my balloon. And a balloon is created to withstand a certain amount of pressure, but certainly not as much pressure as we're creating here. So, what do you guys expect to happen? Uh-huh. Yeah, I think that's a pretty good expectation.
I think so too. Oh, jeez.
Oh, boy.
This anticipation,
We decided to
man.
use one of our giant balloons due to the
Hey,
fact
that's
that we
really
had a
big.
bigger crowd than normal. And so this is going to exceed our regular expectations.
What is this, Harry Potter? Oh, man. I'm going to, like, hide back here.
Oh, boy.
Oh, boy.
Now, I'm not going to float away because this is not helium. It's nitrogen, the same gases that are in this room. Whoa, baby.
Oh, man. Ah!
Ah! Pressure. Thank you. Thank you very much.
All right, that was pretty cool, kid.
Thank you.
But pressure can also mean atmospheric pressure. As the kid mentioned in his rap, we are literally at the bottom of an ocean of air. There's an actual column of air sitting right on top of your head. In fact, if you make an O with your hand and put that O anywhere on your body, there's about 15 pounds of air pressing in and down and up on you at all times. So I wonder what we can do with that kind of atmospheric pressure.
You know, before we do that, I just wanted to say, you're doing a great job.
Oh, ooh, let's just
That's how we
give
do it in
that
Jersey,
a-
folks. All right,
change
now
that
listen.
a little bit.
There is this thing called atmospheric pressure pushing down on you. Each one of you right now are holding up thousands of pounds of air. I happen to have here a 5-gallon water cooler bottle, but notice that it is empty of water, but it's completely full of what?
Air.
Air pressure is filling every part of the bottle. I'm going to have the air that's inside the bottle leave very quickly, and of course to do that, I'm going to use combustion. May I use your combustion, sir? Thank you, kid. Thanks for sharing. So I have here a liquid fuel. You saw it earlier for the rocket.
All right.
So here's what we're going to do. We're going to spray this into the
Okay,
bottle,
fire.
and some science is going to start to happen inside. It's going to start to change states of matter. It's going to turn from a liquid into a gas, and when we light that gas is going to expand rapidly. That's generally what happens to everything around us when it gets hotter. So hot gas is going to push out of this bottle. Ladies and gentlemen, we call this the Whoosh Bottle. And then I'm going to do something you should never do at home. At precisely the moment this fire has pushed out most of the air inside the bottle, I'm going to put my hand on the bottle, preventing air from being pushed back in, or being pulled back inside. We're going to see lots of pressure pushing from the outside in, very little pressure on the inside, and we should see
All right.
ourselves something fantastic. All right, here we go. Remember, do not try this one at home. This could go badly. One part of the show, I have to be careful. All right, here we go.
Should we be trying it here? All
It
right.
smells like the 60s in there. All right, here we go. That was for the adults. Here we
I'm
go.
gonna remove that last
If the
point
kids
for
ask,
that.
just say, oh, there's a funny thing back. Excuse me?
Bad joke.
Oh, I got more of those. So here we go.
Oh.
Ladies and gentlemen, that is simply the power of air pressure. We have low pressure inside, high pressure on the outside. Pressure always goes from a high to a low, helps airplanes to fly, and gives us our weather. Thank you, ladies and gentlemen.
Everybody give it up for the
back.
beard.
Came back, kid. That was a good round for you. Solid. Both of us solid.
That was
What do
pretty
you got?
solid.
What do you think?
Well, I'm a little partial to fire, so
Sorry, kid.
I'm gonna have to give you that point back.
Okay, but it was good, kid. You did well.
Thank you.
Kid did
Beard.
good, didn't he? Didn't the kid do well? Yeah, he did good.
Let's hear for both of them.
Kid really
Good
did.
pressure demos.
He did great.
Thanks.
I taught him everything.
All right.
A lot.
Back to the hat of science. Up next, let's see what we got. Oh, this is going to be a good round. Up next, we have the science surprise. This is where our athletes can choose what kind of demo they would like to do. It can be about any scientific topic, ones we've talked about, ones we haven't. So, I hope you guys have something prepared. Let's start with the beard.
The beard! Okay, all right, you know what? I brought something just in case there was a surprise category. I brought with me today something that I feel is pretty awesome. I brought with me the Ballinator 3000.
Oh my God.
That's pretty.
Now look, there's actually a lot of science involved here, but you know what? I think it's just more cool if you just kind of shoot it. Basically, this pushes air at about 70 miles an hour. As it constricts through here and it goes through this barrel here, it's going to further increase that velocity. That velocity is going to hit maximum as it leaves here. Once it hits the air resistance is going to begin to slow down the velocity. Ladies and gentlemen, this is going to shoot 30 ping pong balls in your direction, heads up, in about 2.3 seconds. Are you ready?
Woo! All right, let's give him a countdown.
All right.
Are you ready? Ready for a
I'm ready,
countdown?
go ahead.
3, 2, 1.
Hold on, wait. One more time.
All right, don't make me blow the whistle. And 3,
2, 1.
1. Nice job, Beard.
No, wait. I have another magazine. We can do it one more time. I'm always prepared, yeah. Another magazine.
Okay. I like the sound of that.
All right, another countdown. I'm
All
prepared
right.
this time.
One more time. In 3,
3,
2, 1. Nice. Big ball for everybody.
It's like an Easter
Thank
egg
you, ladies
hunt
and
out
gentlemen.
there.
Well done,
Just a young
Paul
man
Beard.
and his Ballinator 3000.
Ballinator 3000.
Ballinator 3000.
Wow.
Everybody okay? I didn't catch anybody.
Some
with
assembly
a-
required.
With a head? All right, good.
All right.
That was a surprise.
That was a big surprise.
Yeah.
That was pretty cool.
It was good.
Nothing like grabbing the audience with ping pong balls.
Everybody
So,
okay? Everyone looks good.
What you got for us, kid?
Well, I'm just thinking about how much pressure it took to blow those balls out there, and then I'm thinking about the pressure that burst that balloon. I'm thinking about air pressure, which you mentioned earlier, and it's got me thinking about a weather phenomenon that uses air pressure to create really high wind speeds. Now, when air moves from high to low pressure, that's really what wind is, and sometimes this wind can do some interesting things, like create tornadoes. See, when the cold air from the north meets that warm air from around the equator, they meet in what we call Tornado Alley. Some of that warm air starts to go what direction? And that cooler air starts to come, and warm air starts to go, and cold air starts to go, and warm air goes, and cold air goes, and warm air goes, and cold air goes, and then it gets hit with wind shear, which turns this vortex onto its side, and we get a tornado. Now, if that tornado pulls down a cloud, you might say, oh boy, a tornado cloud.
No,
If it starts
I wouldn't say that.
You wouldn't? Oh. If it starts to pick up dust, you might go, oh my word, there's a dusty tornado. But if it were to go over an open fire, that's when you might say, oh my, a fire-nado. Ladies and gentlemen, let's see if we can create a fire-nado. So here we have our fire. Here's our hot and our cold air meeting in our imagination. They start to spiral on each other. They get hit with wind shear. That wind shear starts spinning this thing into a vortex, and we create the fire-nado. Can you please put your hands together for the fire-nado?
That is an impressive fire NATO.
That looks good, kid.
I hope to never
That
see
looks
one
good. That's
outside
pretty cool.
a basket.
Yes. Now, okay, there's a couple ways we could put out a fire-nado here on the stage. We could cover it up and take away its oxygen. And if a fire doesn't have oxygen, like we saw, it'll go out. But I have something here that a fire needs too. It needs a certain amount of heat. And if I take away that heat, well, no heat, no fire. And here I've got something that's negative 320 degrees liquid nitrogen. So not like you could put out a household fire with this. You probably don't have it lying around, but I do have it lying around here.
Woo. All right. Nice job, kid. Let's hear it for the kid.
I'm on fire. That was solid. That was good. That was solid.
Fire.
That was good.
So, audience, who do you think? Who thinks the beard won this one? And who thinks it was the kid? Oh, I'm sorry, beard.
Woohoo! That's awesome!
Hey, obviously.
Thank
the kid.
you.
I'm telling you, fire beats all.
I got 3 people.
Yeah. It's probably
The 3 people
who caught the
who clapped for me, see me after the show. I want to say thank you. Seriously.
All righty.
Thank you.
So,
Kid, that was good.
Yeah, that was fun. Yours was cool too.
Thanks, man.
no camaraderie. This is a competition. Get away. All right.
Okay.
Jeez.
We are approaching our last round. We have a tie, so let's see what we can do here.
Wait, what is
Okay.
the score?
Our last round is something we've already talked about. something that's very, very cold that we've seen a bunch of them today. Our last round is going to be about liquid nitrogen.
Okay, I love that stuff. Okay.
So, kid, you were just messing with some. Let's give the beard a chance to play with some liquid nitrogen.
Okay, all right. Let's see. I only have one demonstration today with liquid nitrogen. I have another. I happen to love these 5-gallon coolers.
Sure do.
So if you have any, send them to me, 220 North 20th Street, Philadelphia, Pennsylvania, Franklin Institute. So this one's filled with a little bit of water. I'm going to pour some liquid nitrogen in there. As soon as I do that, it's actually going to start to turn from a liquid into a gas. And we're going to use some safety gear here.
Safety first.
Safety first. We'll get the gloves on.
Oh.
In fact, tell them about, you can actually pour it on your hand or dip your hand in it quickly.
Yeah. So there's something known as the Leaden frost effect. Liquid nitrogen is literally so cold, remember, 320 degrees below zero, that your hand will cause it to evaporate. The temperature of the human body is close to 98.6 degrees Fahrenheit, almost 400 degrees hotter than liquid nitrogen. So if you actually put your hand in some liquid nitrogen, the liquid nitrogen evaporates so quickly that you create this little gas layer around your hand, and you can't really get hurt. Now, if you were to leave your hand in there, humans, while we are 98.6 degrees Fahrenheit, we are also mostly made out of water. And water freezes at 32 degrees Fahrenheit.
What?
So, if you were to leave your hand in there for more than just a second, you would literally get frostbite, have to go to the hospital, and that would be a big pain.
And that's bad.
And that's why we wear cryogenic gloves, special gloves designed to insulate your hand against these types of temperatures.
So here's what's going to happen, folks. I'm going to do something you should never do. I'm going to put liquid nitrogen in this container. It's going to expand into the gas, and I'm going to cap it. Bad idea. Don't do this one at home. Even notice on our doer here, it always has a loose lid. If someone were to do something stupid, this is a safety valve. That valve would pop open before the pressure built to the point that this doer would fail, because that's bad. All right, so here we go. This is going to happen fast. Ladies and gentlemen, I call this the water cooler cannon.
It's a cannon?
Well, why not?
Oh boy, oh boy.
This is a great idea. All right,
This is
goggles, here we
perfect.
go. All right, aim carefully, my friend.
Oh man.
Okay, now right now the pressure's building up. At some point, this cork is going to pop off in spectacular.
Woo!
Did it evaporate? I didn't even see it.
Where did it go?
Did anybody see it?
It's all the way over there.
Let's try it one more time.
Should we do one more time? Nice job, okay.
Oh, don't fail me now.
Oh no. Am I gonna? Don't aim that here.
Give it some time. I like that advice.
I don't know, man.
Keep aiming, bro.
You got 10 seconds.
I see bubbles escaping.
Oh, do we have a leak? So, part of building up pressure is you need an airtight seal. Sometimes it's hard to get an airtight seal. No.
I got it.
No.
I don't have it. Thank you,
All
ladies
right.
and gentlemen. I don't have it. Thought I had it. Okay.
Sorry, Beard.
I know how to deal with this situation.
That's
do we-
fine. The nitrogen's probably out now.
All right, well, let's hear it for the beard. The first one was pretty cool.
He tried.
What is going on with you, kid?
Well, the demo that I'm planning to do can get a little bit damp, so I put some weather gear on. So I'm going to need this liquid nitrogen over here by my setup. Here's what we're doing. I'm about to make a very cool area inside of this trash can. A cool area, negative 320 degrees. If you can see my eyes, you're seeing enough for right now, because what we're going to create is going to go above my eyes and beyond. So I'm going to create a cool energy space right here. And then I have a Gatorade tank, the kind of tank that you dump on your coach's head when you win the championship. But this one is full of scalding hot water, so I would never recommend someone dump this on their coach. Check this out. In a second, when this is really cold, we're going to add our really, really warm water. That warm water has a lot of humidity. And when that humidity gets really, really cold, it can condense back together and form, right here in this room, a cloud.
Ooh. Are
We're
you
about
guys ready to see a
form
cloud?
A giant cloud right here in this room. Let's do this together.
Are you guys ready to see a cloud? I'm ready to see this.
Just a few people are ready for the cloud.
Okie dokie.
Some people are tired of clouds. I get that too.
So let's get it cold in here.
All right.
That's plenty. And then let's add some really humid H2O to this mix. This H2O, a lot of it's going to be a vapor, but you'll quickly see it condense, rapid condensation to form right here in this room a cloud. My friends right here, you're in the cloud zone. Remember, the cloud is just made of water. You'll be perfectly safe. It'll feel lovely on you. For me, I'm going to get a little damp. Here we go. Give me a countdown. In 5, 4, 3, 2, 1.
Woo!
Oh.
Nice job! Let's hear it for the kid! I think
Did you say bigger?
Did you see what we did?
bigger, man.
You guys
want
wanna see bigger?
You guys want to see something bigger?
Are you
I
sure?
think the audience deserves something a little better. Come on.
Okay, you asked
Let me
for
join
it.
you guys.
Okay.
So what do we got
2 liter
here?
Paul,
What's that?
you have the 2 liter?
Yes, sir, I got everything we need, right? This is for you, Judge. I hope you like it. Something a little more spectacular. In fact, you can help us out with this. All right, here we go.
How many are we filling up? Just the one?
Just the one. Ladies and gentlemen, we have here a 2-liter bottle. These bottles, they're normally hold soda. You know how the soda builds up CO2? So these can hold up to 150 to 200 PSI. We're going to put some liquid nitrogen in here, and, well, it's going to, expand that 200 PSI range. We're going to have a failure. A lot of energy is going to be created. And just so it looks really spectacular, we're going to put a bunch of ball pit balls in here. It's kind of like a cartoon exploding. That's how I like to think about it. So let's load this up. This is for you, Judge. I hope you appreciate it. Funnel.
Funnel!
Oh boy.
Yeah, this is a
Funneling
good
up.
idea.
You gonna screw the cap on?
I shall screw the cap on. Yes, we got that. We need about a quarter of this.
Good pour. Good
A
form.
little more. How are we doing?
A little more. We're not at a quarter yet.
All right. I'm excited to see this.
And we're at a quarter.
Yeah.
Yep. We're getting to a half.
Where are you guys?
We're beyond a half.
All right. Okay, I got it.
We're capping.
Ladies and gentlemen, I know a lot of people tell you they don't know how long it's going to take. This is going to take about 18 to 22 seconds. So you have that. Okay, once this is capped, we're in the danger zone. All right, go ahead, ref. Put those balls in there.
And we
So right now, that liquid nitrogen is expanding, and we're going to have ourselves a failure of that bottle. It's going to be spectacular.
Oh boy.
Wow.
That was pretty big.